Okay, moving along. Let me just apologize for the mistakes, the numerous mistakes in the last video. Easy enough to see when you're watching it again, but for some reason, mental block occurs, and you can't really see or think properly. It's funny how that is. Anyway, I filled in the last bit if you've tried on your own, and this was. First, I fixed this problem. This should have been C0, not E0, because that was in group 2, B or whatever. And that's a C. 1, 1, 0, 0 is a C. E0, or whatever, E is this value. And that identifies the Cth grouping, or the last grouping. You will notice that the way I approached doing it this time, which is I look at my other version of this, it's not the same. I never seem to do anything the same way twice, but it seems to work. There was a missing bracket here, by the way, if you're confused. Why if you're trying to compile the other thing and it's giving you an error. To get first the last 6 byte bits, it's the same approach as the case 2. Now for this one, this shift of to get the remaining 2 bits from the bottom part, the same. And this shift up 2 is exactly the same for the top thing. However, in this pattern, we've got two bits already here, and therefore we can only have 4 more bits from this guy. And so if I've shifted that up 2, that would account for these 4. Now that's okay, well that's fine, that just happens to be the case. So we've got 4 of these, and this ending with 3F, that's an F, and that's a 3. 3F is 6 bits, right? We looked at that, and that's why there are 3 Fs occurring all over the place, because we're trying to extract 6 bits worth of something. In this case, that something is the same something as in the previous run. That leaves only 4 more bits remaining, and that is gotten by shifting this by 4 and putting its prefix on E. And I just tried this with a single character. The byte order marker for Unicode, and I know what the answer is supposed to be in that case. It's supposed to come out to, it's supposed to come out to a 3-byte sequence, and it should be this sequence, which is the preamble for UTF-8. Print that out, and there it is, EFBBBF. So it's probably right. How about now just doing it backwards? So now So the second part of this story is doing it backward. And I'll try to go quick. So we have encode, now we want decode. Now in this case, we're starting out with a Unicode stream, and the way that I wrote this, the declaration, I guess, or prototype, was a wildcard. I want a thing such that it extracts wide characters, because we're going from Unicode, UTF-8 to wide characters. And I want to be able to pass in a stream of bytes, a multi-byte stream, in this funny format. So I defined it this way. I'm going to pass in a byte star. Okay. The bytes themselves would be constant. I could say PCBYTE. So those are constant bytes. And reference to. So pointer to constant bytes. And what else? The maximum number of bytes that can be read from this stream, I guess. So, is that how I prototyped it? As a size T. So, okay, I'll just copy this prototype. Well, it's almost the same. So this here size is the number of bytes that can be read starting from this location before you hit the end. I want to keep my PC a bit more compact. Alright. Now, what's this business about? Oops. A reference to a pointer to constant bytes business, you say, I hear you ask. Well, what I want to happen is I don't want the bytes to be modified, but I want this pointer to be modified in such a way that I don't have to think about it. So what I want to do is pass in this buffer of my Unicode bytes. I UTF-8 bytes, and after one call, which extracts a wide character, I would like to be able to repeat and just keep calling this function over and over again and never have to update this myself. I'll let the function do it, and so therefore that makes my life a whole lot easier. And so therefore I need to tell the function how many bytes are actually left. Alright, so that it won't read past the end. So put loading in there. Okay, now how would this work? Well, remember that there are some things that we can say with certainty. We can use cases again. First, if the first thing pointed at, so let's say just byte, byte B1, I guess, star PD in stream. I'm going to probably be needing this again, so I'm saving it off. Now, if B1 is less than 80, then we're done, right? We know what to do in this case. Oh yes, and we can advance this at the same time after reading it. Then we are going to return. Oh, well, we should put an assert here and return as well. Assert. Yeah, it's bigger. Yeah, bigger than 0, not 0. Okay. But if you wanted to be really friendly to someone calling this function, you could take the extra step of doing this. And I want to return 0. I want to return 0 in that case. And assert. But I'd also like to set, I can't really set that. This is 0. Well, what if it's negative? I can't do anything about it. But at least all this is saying is, you see, this can never be negative, right? Because this is an unsigned value. But if somebody makes a mistake and subtracts one pointer that's smaller, bigger than the one being subtracted from, then the value would be negative, something like that. If this were a signed value, chances are, actually maybe just the regular assert for this. It is possible you could have a huge string, but in general it's an error. Just assert it. Never negative. So, you know, if the string was 3 gigs big, right, then this value could be negative, you know, in terms of it being an int, and that wouldn't be an error. But most of the time, the streams are small, so it's more likely that if this is coming back negative, that it's a mistake, and a big number was subtracted from a little number, and that resulted in a great big number by accident. And they should see the assert go off. Whether or not it should be handled here, I don't know. But I'm not going to handle it in release mode. Just assert. Anyway, in this case, the answer is really easy. We just cast our thing as a wildcard. Okay. So it's not less than 80. What if it's no, now we got to look at, we know that that's like the 1F case. So therefore, there is a 1 in this B1 has a 1. is equal to 7. Right? So here's B1. 1 go to the column. So what do we know? Going back to the pattern, using the pattern now. Well, there are at least 3 possibilities. If we see this pattern, right, then we know it's a 3-byte sequence, correct? And if we see this pattern, we know that it's a 2-byte sequence. And if we see one of these, then it's neither, right? Then it's a mistake. So the only possibility, I mean, we only read in full wide characters. A mistake will have been made if we receive one of these on its own. So we can handle that error. So we could say first and assert E1 and so if I did this, that, I should see a 1 in this position, right? I should never have a 0 here. In both cases, there should be a 1. So that is, what is that? 4, and that's a 0. Now if I AND that and I get a 0 back, it shouldn't be 0. In fact, it shouldn't be 40. It should be equal to 40, right? But it's only 1 bit. Well, it should be equal to whatever it is. I don't know what to return. 0. Oh, I know what to return. That's an invalid character. I should do the same above. That's an invalid character as far as Unicode goes. Okay, so what I'm asserting here is that this second bit has to be a 1. And if it isn't a 1, if it's a 0, then this AND would give me a 0 back, right? And processing won't continue. So now at this point, we know we're at this stage. Now it's only a matter of deciding whether or not it's this scenario or this scenario. So all we got to do is test to see if at the top part nibble is an E or not. Right? We don't know what this bit is. Could be anything. But we know that this can never be E because there's a 0 here. So if B1 and E0, say, if that's equal to E0, then it's a third case. Right? Okay. So now we can just try pull out the number from the third case. So we'll call this is case 3. 3 bytes. So we could say byte. No, okay, that's actually okay. byte B2 equals the second byte. Let's just grab them out of the string. Same thing. Now we got our 3 bytes. We're going to do something with them. Oh, now, of course, we have to double check. The size of stream now has to be at least 3. Okay. And now I put a protection in here. If it's less than 3, all I do is to terminate. It means that the last thing was malformed, and so therefore we're going to set the stream this here. Check for 0 for that one. So we need to add 1 to this. Right? It has to be 2, in fact. It wasn't 0, or else it would have gone away. So it had to be 1. What could have been 1 or 2. So what is it? Oh, if it's less than 3, we just add, so plus equals instead. We already added 1, so size of string, including the one that we already added, by the plus plus above, and then return 0. Okay, we could assert. It's a mild assert. Shouldn't happen though, but remember that this is exposed to the outside world, right? This is a function you're calling not internally in your program, really. The data is not internal to your program. It could be coming from the internet or something, and that data could be corrupted. And that doesn't necessarily imply that your program has made a mistake if the data is corrupted. It just means that the data is corrupted. So in fact, I wouldn't even assert that. I would just log that, info trace. Corrupt data. Now, if I work that out right, that should put PB stream should then be pointing exactly at beyond the last character of the stream, and anyone who's calling this will quit. And that'll terminate the loop. Otherwise, it could be 3 or more, and we're okay to take out 2 more. And here I've done that. Now we'll get 3 bytes, and we just need to put them in this, sort of turn them back into a wildcard. Now this is 0, 1, 2, as we've read them in that order, right? Okay, so as a wildcard, the top 4 bits are in the 0th byte, right? This one. So I can take B1 and shift that up by 12, right? So if B1 is some value, right? And it's got this 110 thing in it, but that's, no, sorry, I can't shift it up by 12. I've got to make something of, I've got to make this into B1 into a word. So I could say, I gotta cast this as a word. right? And I'm going to be assigning this to something. And a word I can shift up 12. That's 16 bits. I can go up 12, and that takes a value, whatever that number was. Here's B1. Now you have to imagine that there are another 8 bits if I cast this to a word, right? The unsigned short. And if I shift this up 12, that's 12 there, right? That leaves just the bottom 4 bits of the first byte in the upper 4 bits of the result. See, here's the current scenario looks like this, right? Now if I turn that into a word, that means that it becomes like this. Right? And if I shift it up by 12, that gives me 1, 2, 3, 4, and the rest 0. Okay? Now that accomplishes extracting the top 4 bits of the result. So here we have the top 4 bits of the result. Okay. This isn't done yet, this expression. I'm going to do it all in one line, I think. Okay, now the next byte, B2, contains the next 6 bits. So we would like to take 4 bits of that second byte and add it on to this one. So if we OR that, we want the top, so the 4 bits that we want are these 4, the next 4. So that's that would be gotten by casting the second one as a word. And you could shift it down to knock these off, but we're going to be shifting it back up again. So I would say to just end it with, there's a 1 here, we get rid of that. So 0, 0, and if we end this with zeros here and zeros here, B2, and so it's like that, right? That would certainly pull out these 4 bits, which are the ones that we want. So now what is that number? That's a 3, and that's a C, 8, and it's a C, yeah. 9, A, B, C, yeah. So if we do that, we have a number in, we're going to put a comment here, that looks like this. We'd like to cast this as a word. Okay. And we have our other 4 bits up here all ready to go. And we'd like to take these 4 and put them up here. Now by casting this thing as a word, that means it is zeros for this thing. this expression is just zeros on the top. And if I move that up 6 spaces, that'll put them in the right spot. See? 1, 2, 3, 4, 5, 6. Oops. Yeah, that's right. Just 2 more than the 4 that we would like to place it. So if we take this thing and shift it 6, right? Now we would have filled in the high byte of the result. With brackets here and around the whole thing. And now we just need to figure out the low byte. Now we used 4 of these, and we got 2 left. Now these 2 have got to fit over top of this 1 0 here. First, we can just take out the bottom 2 from B2. So there's still 2 left over we haven't used in B2. Just here, everything as words. I might as well have declared them as words. Now those bits we want are in the lower 2 positions, but we really want them in the upper 2. So we want to shift those up by 6 because we have something. 1, 2, 3, 4, 5, 6, and the ones that we're interested in are these 2, right? Oh yeah, sorry. I'm gonna knock out these 4 here. Well, everything in the top. I gotta end it with 3 first to extract the bottom 2 bits, and then shift the whole thing. So what I've done here, those have been used. Right? There's a 1 0 here that I just killed. That leaves these 2, and now I want to basically take those 2 and move them here. That's a difference of 6. Okay. This could have many brackets. In fact, I'm going to have 1 more bracket. Now I want to OR this with the last 4 bytes. The last 6 bytes of the third byte. These 3 we haven't used yet. So we want these 3 and 3F. That gives us the bottom 6. And that's it, right? We don't have to move these 3, they're already in the right spot. Okay. I could have said W card, but Word and W card C are the same. Are we okay with that? I hope so. Now that's case 3. Otherwise, we're in this scenario. We can insert that B1 and C0 has to be E0 has to be equal to C0. Right? Because either we'll need to handle the case where the top 3 bits are 1, If only the top 2 bits are 1, then that's what a C is. That's the 2 top bits. So ANDing this first byte with 3 bits should only give us 2 bits back, and so we can insert that. Maybe return if it's yes sign. It should return something invalid. Alright. Now, we're in a case it's strange. We went to 3 and now we're on 2. But it doesn't matter. One way or the other. So here we have 5 and 6. So we just need 5 bytes. There are only 2 bytes available. And we need to make another check like this. If this is less than 2, again we have correct bit data, and we want to advance it one more. We already did 1, so we'll just add 1 more to the string, and that should point it to the end. But that's not critical error, not like this. This is an invalid code. We've lost our way. It's completely messed up. This is just the end of the stream. Last character. We lost the last character. Maybe, well, I don't know. It's your choice. It might be recoverable. Alright, so now we made it past that. That means we always have to do this. I can't do this ahead of time. It has to be checked first if it's allowed. Okay, now here's B2. Now that's it. We have B1 and B2. And what we need from B1 are 5 bits out of 11. Right? So there are 6. And we want these 5. We want these 6 and then 5 more. Right? In the answer. So in fact, we want 3 of these bits to remain to be in the high byte of the answer, and 2 over top of here. So that's easy enough. So our answer is going to be B2. So if we shift that down by 2, that puts these if I shift that down by 2, suppose I do that, that turns it into a 3 bits. Oh no, there's still this one thing, but I can add that away. And 7, I suppose. If I do that, no, not 7. 3, add 1 to 5. It's case 2. I shift this down, and I want to keep these 3 and knock out the rest. So the number that corresponds to 3 ones on the bottom is 4 plus 2 plus 1 is 7. That is right, it is 7. 7. Okay, it's still not a word. Let's turn this into a word. And now we got to put that word into, it's better to draw it here. So here's what we got. We've cleared out everything, right? I attached it to a word, so I have this, and I want these three up here, right? So how far is that? 6, 7, 8, 8, right? Oh, of course. We're moving to the next byte. So we shift it up 8. Okay. Nothing, enough brackets. Okay. Now, for the lower part, we would like to take, we tossed away 2 bits there. We kept these 3 from the first byte, and we would now like to take the other 2 that we had forgotten about and put these here. So what I might do is take a, this is one, sorry. We're working with the top, with the first byte. B, 1, and 3 is the bottom 2 bits, and that needs to go up 6, just like before, and that has to be 4 more brackets with the second byte, the 6-bit, last 6 bits, B2 finally, we go around 2, and 3F, favorite number, and we don't have to do anything with that one. And this whole thing should also be a word. Word, should I put the word cast? No. I don't know if it really matters. It probably doesn't. It converts these things to integers anyway. But I'm going to just put brackets around the whole thing and call it a word. And that should do it, I hope. Now, how do we test it? Well, one way to test it would be to see if this works in reverse. One thing to do is to see if it compiles. Of course not. Never does. Bad suffix. Yes, that's true. Check my time. I'm too slow at this. Let's see. Yeah, it's true. What's the next one? I should do more than one at a time, shouldn't I? Brackets. Compile. Okay, so now we're going from, let's suppose we have some bytes. Here, let me declare equals, which that should go in reverse, obviously. This sequence should give us a Unicode identifier. It's illegal, but test it's not illegal. This is not a valid, valid and logically valid, but it's not. You would never want to run into one of these in your stream. So what I do now is I call this cconv this b here. B. No, I can't. That can't move. Well, it could, but I'll make another one. Oops. B. Size of string is 3, and that should give us FEFF. Print that. And F. Quote. Right? Okay. Now exactly about conversion. Piece line messages. Conversion from int to signed unsigned mismatch. This is a put this on the outside. And, it doesn't matter. I don't know how to fix it. Comma. Whoops. Somehow you can make it not do that morning. But why is it complaining? That's not signed. Signed, unsigned, mismatch. I've casted it as a. Wait a minute. Oh, I see. There we go. And chances are it probably failed, but who knows? Come on, quickly. F10. Yeah. FEFF. There it is. Well, I'm surprised that I managed to write it correctly that quickly. I hope it's correct. Okay, sorry for being so lengthy, but you know, what else are you guys do? Okay, now back to the editor. See you.